The four-cycle engine, one of the hardest working machines on the planet. Reliable, diverse, useful power in a compact package. Carefully designed and precisely manufactured to exacting tolerances, the Briggs & Stratton four-cycle engine leads the world in production and quality. Repairing or troubleshooting any small four-cycle engine requires an understanding of the individual cycles. We call this the theory of operation. Let's start with a look at the four strokes. Each cycle is a complete movement or stroke of the piston up or down within the cylinder bore. So each complete set of four cycles represents four strokes of the piston or two rotations of the crankshaft. First comes the intake stroke. The piston moves down in the cylinder bore, allowing atmospheric pressure to fill the void with an air-fuel mixture. In the compression stroke, the piston moves upward in the cylinder bore, compressing the air-fuel mixture. The air-fuel mixture is ignited by the spark plug. The force of the combustion sends the piston back down the cylinder bore in the power stroke. The piston completes the cycle with the exhaust stroke, moving back up the cylinder bore to force the spent air-fuel mixture out of the exhaust system. An important improvement in combustion design is the newer overhead valve configuration. In a traditional L-head configuration, the valves are positioned next to the cylinder bore and move upward and downward by the action of the camshaft and tappets. A more efficient and increasingly more common approach is the overhead valve configuration. These engines might be identified by the abbreviation OHV on their covers. In overhead valve engines, the valves are positioned above the piston. The camshaft moves the valves through a tappet, push rod, and rocker arm. Overhead valve engines provide more efficient combustion by allowing the air-fuel mixture to spread more evenly throughout the combustion chamber. Now let's take a look at each of the four strokes and the components of their operation. Four elements are required in an internal combustion engine to allow it to run. Those elements are air, fuel, compression, and spark. Air and fuel enter the engine through the carburetor. It's the job of the carburetor to supply a mixture of air and fuel that will allow proper combustion. During the intake stroke, the intake valve between the carburetor and combustion chamber opens. This allows atmospheric pressure to force the air-fuel mixture into the cylinder bore as the piston moves downward. Just after the piston reaches the bottom of its travel, or bottom dead center, the cylinder bore contains as much air-fuel mixture as possible. The intake valve closes and the advancing piston returns back up the cylinder bore. This is the compression stroke. The air-fuel mixture is compressed between the piston and cylinder head. When the piston reaches the top of its travel, called top dead center, the air-fuel mixture will be at its optimum ignitability point. A very high voltage is created in the ignition coil. The spark plug enables this high voltage to be discharged into the combustion chamber. The heat created by the spark ignites the gases, creating rapidly expanding superheated gases, forcing the piston down the cylinder bore during the power stroke. When the piston reaches bottom dead center again, the exhaust valve opens. As the piston travels back up the cylinder bore, it forces the spent combustion gases through the exhaust valve and out of the exhaust system. As the piston returns to top dead center, the exhaust valve closes, the intake valve opens, and the four cycles repeat. Every repetition of all four cycles requires two full rotations of the crankshaft, and yet the engine creates power during just one of the four strokes. It's the flywheel that keeps the engine turning throughout the four cycles. Momentum from the power stroke is transferred to the flywheel during the power stroke. This inertia keeps the crankshaft turning during the exhaust, intake, and compression strokes. You might also be aware that some engines, such as those used in some lawnmowers, chainsaws, or other small handheld equipment, operate in two cycles. All of the same requirements for combustion are achieved in one rotation of the crankshaft, with one stroke of the piston up and one stroke down. In the four-cycle engine, four simple steps provide the power to do a lot of work. The intake stroke brings fuel and air into the engine through the open intake valve. The compression stroke squeezes the air-fuel mixture, making the mixture more efficient. The spark plug ignites the compressed air-fuel mixture, providing the engine's power in the power stroke. In the exhaust stroke, the spent combustion gases leave the cylinder bore through the open exhaust valve, and the cycle continues through many engine revolutions per second. Four-cycle engines come in many sizes, designed for many different applications. But with a basic knowledge of four-cycle theory, you can begin to understand how all four-cycle engines function. Understanding four-cycle theory is essential to successful troubleshooting. For more information pertaining to four-cycle theory and engine maintenance, Briggs & Stratton recommends the Small Engine Care and Repair book. If you're interested in more advanced studies, we recommend our Small Engine Textbook. These books and more can be found on our website at www.briggsandstratton.com.